like.
It's like Yamaha.
Well, Greg apparently followed up, I guess, latest theoretical apology. Like it's Sarah.
Oh shit.
Mm-hmm.
Oh, shit. Like Audrey said it'd be anonymous.
I know,
It's like,
right?
how many people do I meet with in a
Hey,
day?
everybody, can you
Like
hear us
obviously
okay?
someone on the staff.
Okay,
So everybody on the side.
thumbs up, great.
Well, she went fast.
That means it's infiltrated our.
I guess the alternative is if you stand here, then
Yeah.
people can hear you. But
Yeah.
I was like, oh, this like new fancy thing exists. How do we connect to it?
Really? Oh my gosh, I have been reading
Yeah,
this.
we can try it.
The asymptotic
Wow.
was like 3%.
If this is the same one, there were some issues, but. Yeah.
We can always.
And a
switch
bunch
back
of
to
it's actually faculty and staff. Yeah.
Hi, Dylan and Stuart. Can you hear me?
How's it going?
Yeah, good. Hey, Stuart. If you want, I think the university policy now is that speakers can take the masks off if that's more clear for recording and for for hearing. But it's up to you. Whatever you feel comfortable with.
Oh, no, that should be great. And you guys can hear us okay? Just want to make sure.
Yeah.
Okay.
Yeah, much better than last time.
Oh, that's interesting.
You see the stuff in our face.
Yeah.
Mac and cheese.
You want to go ahead and the slide deck? We can take it from there. Go for it. Okay.
Well, I can introduce, knowing that some people are probably gonna roll in late, this is a new location for us and I guess it's got lost. But we're super excited to have Stuart and Dylan present today. They're members of CSCS, the Center for Spatial Data Science, which is up in the second floor wing in this building. They gave a talk as part of the Mansueto colloquium last quarter, just when they were getting like a month into this project. It was like really fantastic. So I was like, well, let's bring them back a couple months later to this group to share. Super excited about. So I'll let you any additional intro you want, and I can try to man any questions that come in through the Zoom chat.
Perfect.
Yeah.
All right. Great. Do masking in public. Without food. Okay. Hey everyone, thanks for being here and being here online. Going to do a quick slide deck just to introduce some of the big concepts here, bring everyone up to speed, and then give a little demo of what we've been working on, sort of what is to come next. A quick overview of what we're going to talk about. I'm going to go over kind of what makes a geospatial data dashboard, what are the parts and pieces that go into it, what are the kind of pieces you need to think about and conceptualize and put together. Talk about a little bit where the opportunities to grow, to build new things, and then talk a little bit about what we've been up to and seeing this crazy thing that is in process. So as you were so graciously introduced, I'm Dylan Halpern. It's my time in CSDS, the Healthy Regions and Policy Lab in the Minnesota Institute. And you're associated with CSDS and Carto. So first and foremost, what makes a geospatial data dashboard? And optimistically, what makes it great? So the example I'm going to talk about is a project I've been spending a lot of time on, which is the US COVID Atlas. So this is a geospatial data atlas, broadly a sort of data products, data dashboard about COVID. And so it's really been focused on in-browser analytics, meaning that there's computation done on your computer as opposed to a computer somewhere else. And it really has a focus on temporal spatial data, so being able to scrub backwards and forwards in time, and also doing some basic spatial statistics like hotspots that are going to be a little bit more advanced than a typical dashboard might do. This is built using a custom in-browser model for the data, and then using deck.gl for the mapping, which is a graphics-based library. That's what the GL means, graphics library, and then GeoDa, which is a WebAssembly-based statistics library that we'll talk a little bit about. So case study of sort of where an idea that's somewhat simple gets really complex really fast and this sort of thing is hotspot detection in browsers. This is basically saying you can take some data in the browser, find statistically significant high spots and low spots. That's counties with high areas surrounded by other high areas, low areas surrounded by other low areas. So providing this allows users to statistically assess apparent patterns. And you look at patterns, say, oh, it looks like North Dakota is having a big wave, but how do you prove that statistically? And give a little bit more kind of oomph behind that finding that you're seeing. So this is really meant to be applied flexibly across all the data for the project. So you could look at this for cases, for deaths, and all sorts of different things.
Dylan, can we just have you close the people's video
Oh,
on the
yeah.
screen?
Oh, sure, yeah.
Perfect.
So, oh, thank you, sorry about that.
No.
So the quote unquote backend development, and I have it in quotes because ultimately this is all running in the browser in this case. We're using a WebAssembly compilation target. And basically, WebAssembly is a standard where you can compile from a whole bunch of different languages. Primarily, you'll see C++, Go, Rust, and a couple of others, and then run them at near native speeds. The great thing about WebAssembly is you have security, so you kind of have some guardrails on what that program can and cannot do. So this runs in the browser, and it's universally accepted, has been for a few years now. So Shun Li, who's with CSDS, built this library GeoDa, which takes a lot of the core functions of GeoDa for producing spatial indices, for binning data and putting it into discrete bins, for doing these sorts of hotspot mapping, and makes it available through the browser directly. And there we go. So to kind of put the pieces together, for our data management for this project, we had the GeoJSON, which was the actual boundaries, the geometries, and then the CSVs joined together. Now we had these separate out and it's evolved a little bit, but this is all to kind of optimize the data, especially for 2 years of COVID data. We have a lot of data coming in. So any optimizations we could do, we had to. This was then brought in through kind of array buffers into WebAssembly to read in the data properly, and then in browser tabular join. There are also a lot of cartography and design considerations. So we had multiple different map modes. So we talked about the hotspot map. We also had just a normal colored map, as well as a box map. We had 3D maps, we had 2D maps. And it's not only the kind of technical requirements, but also how do you design ways to control these, ways to communicate to the users what's going on here. There are also issues of data ambiguity. So for a hotspot map where red is kind of a high area and blue is a low area, if you look at a vaccination map, it's actually red is good and blue is bad. The vaccination rates you want to be high. So there's data ambiguity that you run into in sort of communication. There's also some user experience concerns that went into that list. So all of this kind of advanced spatial stat stuff is super cool, but it means that the web browser is doing a lot at once. So we then had to figure out, okay, how do you break this out and multi-thread the application? So you can have one processor or one process doing the spatial stats while the other is drawing the map, while the other is doing the interface. You get a lot going on. So this is sort of, and I won't go through all this in the interest of time, but these are kind of the scatter shot of challenges you have to think about when you're having like an advanced, especially geospatial, but especially temporal data dashboard or data product. These are kind of all the things that go into it. From how is the data managed, where does the data live, how are statistics calculated, and so on. And then really ultimately what a lot of people should and do want to focus on that stakeholder engagement, thinking about what is important about the communication, what are the important insights, and really being able to kind of raise those up to the top and get the technology out. So this is the intimidating wall of icons of all the libraries and technologies that you may or may not need to use. Maybe some of these are fake and I threw them in there. And Stuart is probably looking for it now. They're all so these are a collection of possibly the sorts of range of different technologies and libraries that you need to start to build something like this from scratch. And that's great if you have a team of developers, but it's less great if you're an analyst or a scientist or a data worker trying to figure this stuff out, and it's a mountain of stuff to just get started. So you're an organization. Here's the list of positions you need to fill, and on top of that, you'd have so many people. You need someone just to manage them, and so it gets really overwhelming really quickly. It can do. So what we're trying to do and what we're trying to approach is think about how to simplify these tools to take the complex state management of a geospatial data app and make that a little bit easier to wrap your mind around, to connect a bunch of different data formats together in kind of a cohesive way, to think about complex analyses and how to run those, and also setting up the environment to do so and for that infrastructure, to join tabular data to boundaries and kind of handle these data in optimal ways, as well as ETL pipelines. And then also thinking about how do you do this collaboratively across multiple team members with different technical backgrounds, different capacities, and bring that all together in a way that's accessible and approachable. So next question is, what's already going on? Who's already solving these problems? because there are a lot of great solutions out there. But our question is, where is there room to grow and build on top of these existing technologies? So we have this sort of evolving collection of different technologies, and you'll see some that might be familiar. We bring up Carto, ESRI, Spatial, a couple libraries like that. And then also some ones that no longer exist. So Fusion Tables was a Google product that used to be a great example where you could basically dump your data into a spreadsheet, puts it onto a map. It's really fast, easy to use, but that project has been sunset and no longer exists. We're sort of bending this roughly into thinking about how things integrate across different ecosystems, the applications themselves, something like Tableau or Power BI, where it's really like an end product for data, services, which is a lot of what ESRI provides, right? They're giving you the spatial database, or something like a library, something like a GeoPandas or like GeoDa, which is really kind of a part of your analytical stack that comes with that. So if we think about an all-in-one project, something where you bring in your data, you have your database and your dashboard all in one place. This is really thinking about things like our Shiny, Boca, Plotly, which these are really excellent for one-off projects. If it's a school project or kind of a singular effort, these are really powerful tools to kind of crank that out. But some of the challenges with these is they can be tricky to collaborate on. Picking on our Shiny for a sec, oftentimes you end up with a 3,000 line file, and then you end up in merge conflict hell, and it really can be a lot of work just managing. And also long-term maintenance can also be a challenge, thinking about how these tools exist over time. And also related to that, kind of hosting them cheaply isn't always the easiest option. Again, picking on Shiny, Shiny Apps is a great service to be able to deploy it, but it's pretty limited in terms of what sort of bandwidth, how many users, and that sort of thing. For data exploration tools, really first and foremost here is Kepler. And I guess it's sort of the child of Kepler, which is unfolded. These are really quick and easy ways to put data on the map, and just be able to look at it and explore it and get a sense of what's going on. And Kepler is tremendous for this. Really, really quick, really fast, pretty straightforward to use. But it really is focused on this data exploration and visualization. And so the use cases for putting it in front of an audience are a little bit more limited in terms of creating kind of a complete package, explaining the data, showing the context, and kind of showing what the analysis was. It is really high performance. But in terms of the data management, if you really want to get the most out of it, you kind of need another suite of tools. So last but not least, there are the commercial platforms, which are generally excellent in terms of user experience. They can reach a broad audience, they're really powerful, but they can be expensive and can get really expensive really quickly. And you don't always know what the pricing is going to look like in the future. And beyond that, they're not guaranteed to exist. Thinking about Fusion Tables for Google, things go away, and the tools you might like might not always exist. There are also some questions with data privacy. If you're working with sensitive data or data that you wouldn't necessarily want on remote servers, there are questions about kind of who owns that data and how does that exist. Additionally, because these are driven by kind of the big clients that might be working with Tableau or so on, there might be limited use cases in terms of your particular interests. So an example, a tweet here that said, WTF happened to Carto. It's not really possible to use with raw SQL. So originally Carto really gave you really close access to the underlying SQL table, and you could basically just use it as a spatial database with an API. But it's been more and more locked down unless you're in one of the more expensive teams. So what are some of the needs that we've been starting to identify here? First is a low barrier to entry with a high ceiling for complexity, meaning that it's easy to get a foot in the door, but you have a lot of flexibility and freedom in terms of actually doing the sorts of things you want to do. Technical abstraction, meaning getting the technical, boring, boilerplate stuff out of the way so you can focus on those important things, the analysis, the insights, the engagement with stakeholders, and then accessibility and collaboration, meaning that more people can work on it together and more people can use that platform at the end of the day. And lastly, flexibility and extensibility. We're working on this now, but we're hoping that in the future there will be more people working on it, bringing in their expertise, insights, and capacities that we may be missing to fill in blind spots and to figure out what comes next. So what comes next? I think I'll pass it over to Stuart here to talk a little bit about what's been going on and a little bit of a demo.
All right, thanks, Ellen. So yeah, really kind of what we've been doing is trying to build a set of tools and an ecosystem, as Dylan was mentioning, that kind of brings a lot of these things together and makes it really easy for people to use this stuff and can be like really made extensible and editable as you go along. And really what we're coming down to is this idea of like really boiling down a dashboard to like sort of like semantically 4 different things. There's like the data that you're pulling in from the world. So that could be coming in from your own database. It could be coming in from some raster file in the cloud. It could be coming in from an API somewhere. Some kind of specification which describes how to take that data and take what you want to build, so the kind of like where you want things to be. So there should be a map here, it should be these colors, there should be pulling from this data set, there's a chart here, it should be pulling data from this data set, etc. So that kind of being our specification. And then finally a state, which is what the user's currently done in the application. So if you imagine these 3 things, you've got kind of the data that you're pulling in to use, you've got the specification that says what the dashboard should look like and how it should work. And then at every given moment, the user's gone in and played around with that dashboard and tweaked some things, and that should be the state. And that's essentially all there really is to building out the dashboard. And then you kind of combine all these things together in one big like piece of code in the middle, which is what we're writing for everybody. And then it spits out something beautiful that gets up on the internet and wins you prizes for data, like insight and discovery and whatnot. And so that's what we're kind of trying to build out here in a lot of different ways. We're calling it Matico, which we can talk a little bit about where that comes from, if anybody's interested. But it's this whole kind of ecosystem of tools that kind of come together to make that one big kind of like task of building a dashboard easier. It's really designed to be modular. So if any one of these pieces is something you want to use, you can grab it out and use it by itself, but they all kind of like work together in a nice way to kind of come together and make things easier. So we've got an editor, which is the thing that you use to create the specification for your dashboard. So that's the thing where you can sort of, click and drag around and tweak things and change colors and change text, etc. That you need to write 0 code for. That's all just like, drag and drop, like tweak things with like, text boxes and these sliders and things. We've got a server for where you store your data. So the editor, which as we'll see in the demo, can really pull data in from anywhere. It can pull data in from the web. So if there's a CSV or a GeoJSON or a raster somewhere that you want to bring into your dashboard and it already exists out there, you can pull that in directly. But then if you want to control the data, like if you want to actually update it or edit it or allow people to kind of add to it, for example. So in this case, this might be like a community management project where you have a lot of assets that you want to give many different stakeholders access to updating and changing, then you can put it on the server. The server then holds that data and gives you tools to edit, update, and tweak that data. And then we have these other components like Matico component library, which is the little parts that come together to create the dashboard. So like the actual kind of like scatter plots or the histograms or the maps, etc. And that again is very modular. So we're using deck.gl, as Dylan was mentioning. It's kind of one of the standout sort of data visualization libraries for maps. But if you really like other mapping solutions like Leaflet or like open layers or something similar, the component system is flexible enough that you can swap that out. And as long as it adheres to certain set of standards, you should be able to use that in place of what you want to do. So the idea here is not to lock anybody into using the particular set of tools that we really care about. As long as you can make your tools respond in a certain way, you should be able to just drop them in and replace the components that we're building out for these dashboards. And then finally, we've got a compute framework, which is the more nascent thing just now. We've got a couple of examples of that. We're working on that over the summer. But that's using this WebAssembly environment that Dylan was talking about, which gives us the ability to take code that's written in something close to JavaScript, something Rust or Go or C, and kind of bundle it into these little packages of code that we can run very, very quickly and can make it portable as well. One of the nicest things about WebAssembly is that it's a kind of secure environment. So, normally if you hand me a Python library or a R library, I just run it and hope that you're not doing anything malicious on my computer. But there's been a lot of things recently where people are downloading NPM modules or Python modules, and then it does the thing it says it does, but then it's also running a Bitcoin miner in the background, right? And there's no real way to stop that, given the sort of the modular models of these languages. So one of the things that WebAssembly does really well is it gives you this like encapsulated environment where you get to specify very clearly what permissions you give code to run with. It's not allowed to access any files, access any resources, access any sort of APIs that you don't allow it to access. And so it allows us to do things like, somebody in this room could write a really amazing machine learning algorithm for detecting, I don't know, like trees and like raster data. And you could bundle that up as a WebAssembly module and send it to me, and I can run that and give it like very strict access to things and be sure that I can trust that code. So what we're doing with Matico Compute is trying to build a sort of a standardization around what those modules look like, how they pass data between each other, kind of what format they expect, like geospatial data to be in, all that good stuff to kind of make it so that these things can be like pieced together into kind of a pipeline that makes a lot of sense. And so we're kind of trying to build this with a couple of different like base principles. One of which is that data part. So whenever we talk about these kind of projects, we always ask, well, where does this data get stored? Like where do I store my data? Do I have to pay for that? Do I have to build a server, like have a server running for the data storage? And I think our philosophy is that eventually somebody needs to hold the data, and it may as well be you. So this idea again of like really kind of data ownership and infrastructure ownership is really key to what we're doing here. So what we're doing is trying to make this entire thing easy for you to sort of like create your own instance of on like a hosting platform like AWS or Heroku or something similar. Make it so easy that you can just like run one command or click one button and it'll be deployed and it'll all be good and ready to go. But then you really kind of own that infrastructure and it's yours to do with as you please. And that means that if you want to be confident that it's going to be there 10 years down the line, 20 years down the line, all you have to do is make sure that this is up and running and still going. And we're planning on making it so that as we update the core infrastructure, you can pull in those updates, so you can always update your own server. But the idea is that everybody kind of runs their own little server. And by everybody, I don't mean like everybody in this room. Like it'd be most likely be kind of like a department here at the university, or the university itself running an instance of this and then giving access to students and members of faculty here. But really, this is kind of core. Like we want to be able to not have to rely on somebody else to host their infrastructure. We want to be able to do that ourselves. And so this is kind of Matico server. It's changed a little bit since the screenshot, and you're going to see the work that we've been doing in the past like few months. But this is kind of like the server structure, and it allows you to upload data to it. It then gives you a set of APIs to interact with that data, and also a web interface to interact with that data. So once you've loaded data into the system, and we support CSV and GeoJSON, we're going to be shortly supporting shapefiles. And we're beginning to explore how to bring in raster data and support that in an interesting way. I can show you an example of that, but it's very, very new. And if any of you who's listening to this call is interested in helping us figure out what raster stuff we should support, then like feel free to reach out to me after the talk. We'd love to chat to you and like really kind of nail down use cases there. And it allows people the ability to easily update the data set. You're going to see in the demo, like updating a geometry here is as simple as clicking on it and then seeing the points that define it and be able to drag those around and change the structure of the geometry. Changing the data itself is just as simple as clicking on one of the columns here, or one of the rows here, and just changing it in the user interface. And so this makes it really easy. But what this also gives us is APIs as well. So if you want to define an API around your data set, so let's say you have a data set of, I don't know, like drive times to like clinics or something, and you want to create an API where you kind of average that over a certain geographic region, or you put in a point and it works out how far away everything else is from it. You can define those APIs really easily with the server, and then like allow people to use them either in their own applications or use them in the applications developed with Matico. So there's kind of a nice like way of doing interesting APIs there, which we'll see as well. And then behind the scenes, this is currently like PostGIS. So like all the data that you upload, all the data you're editing is all living in PostGIS. But we're also exploring different backgrounds as well. And that's again modular in such a way that hopefully we're going to be able to support doing that in a MongoDB database, or maybe something like Amazon Redshift. And as I say, like other raster stores as well, where we're playing around a lot with cloud optimized geotiffs as a way of like accessing and processing raster data through the system as well. So again, like an extensible environment to do really interesting things with. The other part of this that kind of then people bring up is, well, okay, let's say, I want to use this. I've got my own server. I've got my own, like our University of Chicago's got their own server. I've loaded some data there. That's really great. But if I do this on a platform like ArcGIS, I could share my data with anybody in the world really easily because it's all on the same platform. That's great and all, but we can also do that with this system as well. And again, this is something we're going to be building out later this summer. But the idea will eventually be to use something called a federated system, which allows us to let anybody set up a server and let the servers discover each other and talk to each other and exchange data sets, exchange, applications, exchange, even like compute codes using this like WASM binary format to like securely and sort of, trustworthily listens to share that like code around. And those systems are kind of like they're governed by something called ActivityPub, which is like a WebC3 standard. It's used in Mastodon, if anybody's used that, the Twitter clone, where people can have their own Twitter servers and talk to each other. So the idea is to leverage that API to allow the different servers to talk to each other and really kind of allow you to share data between instances. That's really cool. Another key principle that we're really trying to build out with this platform is to make it so that people don't necessarily need to know about geospatial concepts to use it. Like if you find a GeoJSON file or a CSV with an ID in it, you shouldn't have to be somebody who's taken a course in GIS to like use this stuff, right? You should be able to like drag and drop this on and then be able to edit it like you would a spreadsheet or you know, something similar. And so we're really trying to make, you know, this as easy as possible, to the point whereby Dylan's written a really cool little tool for like administrative data sets, where if you upload like a CSV with like a FIPS code from the census or like a zip code or something similar, the code kind of guesses what the idea is, and then we'll automatically join that with the polygons and the geometry you need to represent that as a geospatial data set. So again, really trying to be good about not having to make people jump through hoops to get like their data and use it. And then finally, this other principle we're really looking at is this idea that when you're building out applications, when you're building out these dashboards, it shouldn't require you to be a developer to update them. So one of the things we find a lot with things like the Code Dashboard or other dashboards I've helped build in the past, like I worked a lot on early census work this past census in New York, trying to get the early vote work out. And I was like the only developer in that project, and I was doing it kind of as a volunteer effort. And one of the problems was like when it was updating something technical like the data, I was happy to do that, but then often it would also require me updating the text on the website as well. And it shouldn't require me as a developer to update text on a website. That should just be somebody's job to go in and just click on it and update the text, right? So if you want to change like some text in your application or your dashboard, it really shouldn't require, you know, you learning code or knowing how to work Git or anything else. So again, that's something we're building into this. And so that's kind of what we're doing with Matico components and the dashboards. This is an ideal spec. I'm actually going to skip through some of these and show you kind of what the build looks like, so we can go into the demo. I think that's probably good. Yeah. All right, we'll go back to those in a bit. So let me just switch computers. This is going to be the tricky part. Actually, find my computer first. Okay, there. Yeah. So we're just going to switch over computers after the demo. So just give us 2 seconds. While we're doing that, is there any questions from anybody in the Zoom chat or in the room here about kind of the basic idea of what we're building and the basic idea of what we're producing?
I guess I have a question of whether you have other clients already. Have you had some test clients to sort of beta test what you have so far?
Age of like getting like to test this for sure. We're basically planning on doing an early alpha release for AAG in a few months time. I don't know, a few months time, a few weeks time even. So at that point, we'll have the code available for people to use. Sorry, my computer's going a little bit crazy here. At that point, we'll have the code available for people to download and use on their own. We're going to set up a demo server as well, so people can just like log into the demo server and use that, and try and like really build out the applications that way. So yeah, at the end of the talk, we're going to put up a URL where you can sign up for updates on our mailing list. The best thing to do is get on there, and then once we've got a version that's ready to share, we'll let everybody know. And we'd love to hear about use cases and talk to you individually to do that.
Yeah, I just wondered if there was like time to have, I mean, maybe you've already done this, but have a working, just a kind of a preliminary meeting about people talking about use cases.
Yeah, we'd love that. That'd be great.
I can just imagine having a little seminar where people just come and sit around and talk about.
Yeah, for sure. That'd be awesome. I think that'd be really good to do. So I'm gonna hand over to Dylan to answer any other questions. I'm just like struggling a little bit to get the computer to work here.
Yeah, I see Jim, your hand is up if you want to go ahead.
Yeah, so if I understand it correctly, do I have to like own the data, or can we like point to like public sources of data like on Google Cloud or something like that? I really don't want to own the data. So like, but it sounds cool if we can like kind of point to these things. Does that make sense?
Yeah, absolutely. So yeah, we're really trying to make it sort of like a modular, basically like an adapter to connect the different parts and pieces, right? So as it is right now, we have the capacity to, you could point it at a CSV or a GeoJSON data set that's hosted somewhere else, right? You could be an endpoint from Socrata, could be, any sort of data set. Longer term, yeah, definitely thinking about connecting with existing and popular data stores, things like, Google BigQuery. If there's a public table that gets updated, being able to just ping that. Or I mean, for the static data for the GeoJSON, another example is like the New York Times, right? They have a CSV and GeoJSON repository of data, just of like COVID data, for instance. You're definitely able to just kind of point to that and pull that in for sure. And you can either choose to have that kind of pull in and then you have your own instance on the server, or you just pull it in directly and just kind of wherever they host that data is the source of truth there.
Cool, amazing, thanks.
Okay, so I've got my screen presenting here. I'm just going to find Zoom. Sorry for this, it's a little bit finicky. There we go. And I can share my screen, hopefully.
Yeah, I'll keep my microphone on over here just for simplicity.
Okay, can everybody see the screen? Everybody remotely? Feel it good?
Can you all still hear us okay over Zoom? I think we're getting thumbs
Okay,
up.
great. So this is gonna be a little bit weird because I could only get this working if I only had the projector screen on. So I'm gonna have to like do this on the projector screen. So apologies if this is a little bit awkward. But this is our basic kind of like homepage for the Matico servers. This is kind of like where we're starting off from. As I said before, everything we're doing is modular. So if you don't want to use a server, you can also just like go straight to the application builder, which apparently is running just now. And as we'll see that it can be working standalone. So again, it's all modular. If you just want to use a static spec version of this, where you're not hosting any data yourself, just like the question was asking, you want to pull it in from other sources, you don't even need to run the server itself. You could just run the editor as a static web page and then download the specification that comes out of that. And that's enough then to create the dashboard. So you can do it without any server whatsoever, which is kind of nice. But let's have a look at kind of what the server looks like itself, just first off. So we've got these 4 tabs at the top, 3 tabs at the top that are kind of the core different aspects of the server. We have data sets, we have apps, we have APIs, and those are the things we can sort of basically control through the system here. So as you can see here, I've loaded some data sets in. If we want to put data sets into our database, we can upload them really easily. So if I come in here and go to downloads, I can see a file in here that I might be interested in. So for example, maybe this county US facts, which is a data set that Dylan's been using. If I open that up, it should display me a little, sorry, the resolution is a little bit weird here. Let me just see if I can zoom this out a little bit. Basically, we see a little preview of the table with all the columns in it, and we can sort of tweak things a little bit here to bring that data set in. We can give it a name and a description, and we can sort of set it to be public. So if I just click upload, that uploads this to the server, and it puts it into our database and makes it ready for us to use. That was the sort of the GeoJSON version of this, but we can also do this with CSVs, in which case we have to specify kind of a long column, or we can build a synchronizing data set. So this is our sync interface here as well. So if there's a data set out there in the world that you want to do something with, but updates every, say, day, what you can do is you can sort of specify the URL of that data set. Thanks, that's much better. Cheers. You can specify the URL of that data set, and you can give it a name and a description, and then tell this to pull that data set in every, say, 24 hours. We have a ability in the backend for this now as well, to be able to not only do that, but then run it through an ETL process. So allow you to basically write a SQL script that will then clean the data, transform the data before it gets put into the database. And this is really important because obviously, like often the data you find online is not in the format you would want it. Maybe you sometimes have to like drop duplicates. You have to kind of rename columns. You have to kind of remap IDs in there to something else. And so the ability to like basically tag this with a script that will bring the data in, run through that script, and then update that data in the database means that you can create something that is quite flexible and allows you to build dashboards and build APIs and build applications out that basically you have sort of control over the data format and the data shape. I won't show that just now, but that's something we can do and play around with. And then once we've got a data set, we can sort of have a look at it directly. So if I click here, it should take us through to the data set. Just give it a second or two to load up. And once we're in the data set view, you'll see that we get a tile server here. So basically we can see the data on a map. We can do things like specify what column should be used as an ID, what column should be used as a geometry, whether or not it's public. And we can sort of really kind of look at this data in a number of different ways. So we can see all of the columns we have here and a representation of the data that's there. We can zoom out to the extent of the data set, which is nice if you want to just like see things quickly. And then we can do things like take a look at the population and see like a little histogram. We're working on tidying these charts up a little bit. They're kind of like, you know, add a little bit, like got a little bit of UI jank in there just now, but we're kind of working on that. Or we can see what that looks like in the map just by clicking this button here. So we can sort of visualize it really, really quickly. And so this gives us a way to explore the data set, really kind of play around with it, see what's in there, see what's interesting, see what's not interesting. But as I was saying, this is also then useful to edit the data as well. So let's say if we come in here, we know something is wrong, maybe with this county. If I click on this county, oh, hang on, might need to refresh this slightly. As I say, this is very, very new. We're just still working on this. This is like the development server on my machine, so you might see some errors occasionally. So if I click on this now, we see that we get all the columns that are there and the values that are there for this particular row in the data set. We can also do that by clicking on, we actually see what the column, the geometry is for that data set. And we can also do this by just clicking on the geometry as well. So if I go to New York and say, actually, you know what, I've been talking to somebody and the number of hospital beds for COVID in New York is actually higher than I think. I can update that, save the changes, and then that updates the data set. And so this means that like if you've got multiple stakeholders in a project who are like domain experts and really can control the data, they can go in and really sort of curate the data and tweak it and change it as they're playing around with this. And it doesn't require them to use a database. Yeah, you got a question?
Is there any sort of like record for these changes to make it like more reproducible?
Yeah, that's a good question. It's something we're thinking about doing. We don't currently have it just now, but it'd be really interesting to do kind of like a little audit trail of like how things have changed to make sure that you can go back and maybe see an older version of the data. The changes, I guess some of the questions about that would be things like if you did a bulk change in a column. So we were hoping at some point to be able to, come in here and select one of these columns and say replace all the values of X with Y, for example, right? And how do we store that in a way that's not just creating a huge amount of data in the database? But yeah, for sure, that's something we definitely want to do and have that audit trail, because we know that's really important for data like lineage and integrity, etc.
Especially in collaborating with different people, it gets hectic.
Lynn also raised her hand. I don't know if she's
Oh, yeah.
from here, if you want to tell her.
Yeah, two questions, and my Wi-Fi was crummy, so you might have answered them already. The first is, what happens if you have two data sets with different dimensions of the areas? So like one is a gridded data on a regular grid, and the other is sort of county level data on irregular counties. Can you do analytics that way, or can you even overlay them, or do you have to have a single grid when you're representing data?
Yeah, no, the data sets currently we're using, so the first set of use cases we have for this are more through the kind of the social data sort of side of things. So it's a lot of like vectorized data. So there, the data, each row basically just has a geometry associated with it, which can be like a point line or polygon, and it doesn't really matter what that geometry is. We are also looking at allowing analysis with rasters, and the way that we're trying to support that just now, at least in the first case, is to use, as I said, like cloud optimized geotiffs, which we'll show an example of. And within that, you can create a table within the database that allows you to query those and reference those, and then combine those with like the vectorized data. So for example, if you had a series of points, the data set I'm going to be showing later on for rasters is a light pollution map of light pollution from the satellites across the entire world. If you had a bunch of points, you could write a SQL query, which again, we can turn into an API that then will do like aggregations of the light pollution 20 miles from like any one of those points and provide that as a data set. So you can do some processing. Again, this is something we'd really love to talk to people who work more with raster data about, like if there is, the requirement or need to bring more of that into the core application, it'd be really interesting to talk through that and see how that works.
Or even if you had vector data, like imagine you have like wards in Chicago, and then you also have, census tracts or something which are different, and you're trying to overlay them and do some sort of analysis that includes things that are sampled on different.
Totally. That's still easy to do. So we can bring in those two different data sets with different geometries, and then you can combine them either kind of visually through overlaying the different layers, or you can run queries against the different ones. And we'll see that in the app building side of things a little bit later on. So like we don't have any, this view here is more about data curation, data cleaning, and data management. And then the application building is what we're going to show next.
Okay, good. So it's a small question, and you can also you can have a time dimension, so you can have a data set that's sliced up in time units and play a movie forward.
Yeah, that's exactly. We don't have that control built into the system on the app building yet, but it's easy enough just to like add that in and sort of create that time scrubber. So that's one of the things we're going to be working on. I think probably post AAG is like that kind of time component of things. So again, yeah, like here you can see we're able to specify a column for the ID in the data set and a column for the geometry, but you can imagine having one in there which also like specifies a column to use as the time dimension as well.
Exactly, and then you just blink it forward in time.
Exactly. And there's other ways of potentially doing that as well. We could potentially either do that through having multiple rows that reference the same geometry at different times, or having a single row where there's like maybe an array on there, which is the different numbers to the time as well. So there's different ways of doing that, which we can definitely build into the system pretty easily.
Also, so that's part of your plan, but not implemented yet.
Yep, exactly. And we want to build this out with the community. So this is why we're like having these talks, right? If that's a feature that people really want, we want to like focus on bringing that in.
Okay. I was also going to note one more thing for thinking about different kind of workloads, in addition to kind of the built-in PostGIS, spatial stats that you could do to do joins. The other thing to bear in mind is further down the road with the kind of Matico compute and WebAssembly idea, you could write your own kind of custom analytic module that does kind of whatever sort of analysis you're looking for. Right now, definitely C, Rust, Go, Python is on its way. R, I'm not as optimistic on, but
Yeah.
Python in the semi-near future, I think is gonna be pretty accessible. And basically just plug that in and say, okay, as part of my analytic pipeline, pull in the data, do this analytic module, output the result to the database is kind of one of the styles of workflows that we're targeting.
Yeah.
So just for even for people who work with raster data, there's a huge amount of effort that's always spent rebinning things because they come on different grids. Right.
Yeah,
So it's this
sure.
constant problem, the raster data, the fact that this raster data doesn't solve that problem for you. It's, if you say, I want to do some sort of analysis on two things that are sampled in different spatial frequencies, how do I deal with that? But if you have a standard module for doing that and people who just upload data and then describe, well, how do I want to interpolate, choice A, B, C, or D, that would be amazing.
Yeah, let's connect after the talk and talk through that in more detail to get to really nail down what that would look like, because I think that would be really, really handy.
Cool.
To kind of get back to the editor here as well. So we saw kind of how to edit the tabular data, so the numbers associated with the geometry. But if we actually want to edit the geometry itself, we can do that too. We just click this button and we get our anchor points for the different points here. So if I wanted to make Long Island even longer, I can do that. I can add in a new point here as well, make it look really weird. And then I just save. And that's then updated the geometry. So you can have these godlike powers of rearranging US states if you want. You can do some gerrymandering on there if you really want. And that's kind of our data set view. So you can do that for all the different types of data sets. You can upload points, polygons, etc. Just vector data just now. Again, raster data is something we're thinking about, but we want to be careful about how we approach that and bring it in. So then the next thing we can do is think about APIs. So we have these data sets in our database now, and you might want to combine multiple ones together and query them in different ways. And so what we have is the ability to build out APIs, and this is pretty simple. So what we do here is if we click through to one of these, give it a second or two to load up. There you go. We basically get a table view showing the output of the API that we're going to be building. We see the variables that are in there as inputs to the API, and then we see if there's any geospatial data, kind of what the API looks like for the geospatial data. So this is a really simple one where we're just saying select, and we're building these out using SQL. So basically this is a little SQL statement that runs, and we're basically adding in placeholders for different things here. So this is like the simplest one you can imagine. It's just saying select whatever number is and return the number. So in this case, you can see the output here is 10. The input variable here is part of the system here. If I change that, I get the output changing. This is like the simplest, dumbest thing you possibly do, right? This is like, you'd never do this, but this is showing you the idea. So essentially what we do is we combine this query here, which we can make quite complex. This thing could then do like a spatial join. It could do an aggregation. It could do, reference a raster file, for example, and pull that in and like do some computation with the raster along with the vector data set. And then you can have these little parameters that you just add in here to sort of have those as APIs endpoints. So for example, if I do, this, for example, so number plus number 2, I can actually spell, and just put a little $sign here. These things get replaced by the input variables. And so if I do that, I get a new input variable added here. I can give it a default value, which is what it gets used if it's not set. And then if you see here, if I run this, a query output should be then the addition of number 1 and number 2. So again, it's a really simple, dumb example here, but the idea is we can use a complex query here to build up an API endpoint. And then basically you get this URL where you just pass in those variables and it will return you the data in whatever format you want as an output of that. It also gives you a tail set as well. So let's do a slightly more interesting one of these. So we come in here. Oh, sorry. Oh, got 10 minutes left. Okay, cool, great. We'll get through this quickly. So that's the wrong screen. If we go to APIs very, very quickly, we can do like some kind of spatial query. Do a good one here. No, that's not a great one. But you get the idea, right? We could build out something really interesting here, and then that becomes an API that you can use to query stuff. So sorry, I thought I had a better one loaded in here, but we can get to that there. Yeah, okay. So for example, here's like a more like interesting query, right? Where we're pulling in a raster, and we're doing an aggregation of that raster value within some convex call like area, right? And we could then have like the latitude and longitude for that be an input to the query. So essentially then you've got an API endpoint that when you click, it will give you back the raster aggregated around that long. And as well, it will also return a GeoJSON object that shows the buffer with the value associated with it, right? So that's really powerful because then you can start defining really interesting, intricate APIs based upon the data sets in your data system. So that's the API. So I won't talk too much more about that because we're a little bit short on time. But let's get to the real fun parts. the actual app building. So again, this can be done with or without the server. We're going to do it with the server here. We're going to build a new application. So we're going to say new application. We can call it something here. So we say demo, some description, which is nonsense right now. And we go to confirm, and that creates a little new application for us. If we come in here, this is what our application looks like. It's very exciting. There's nothing in there yet. It's pretty blank. But if I just go to edit here, actually, it's harder to do when I can't see my screen. So I just click through here to the edit button. We get our application builder. So that we've seen the same thing as we saw before, but now I can start doing interesting things. So first thing I can do is add a page. This is the first page here. We can add some text to it. And as you see, the text updates like in real time. So again, if you wanted to write an introduction page or something similar, right, you could do that really easily. In fact, let's do that. Let's add in a page here, which is going to be something like our info page. So I can change the icon. So it's now like a little cute little like bulb here. And I'm not going to write a bunch of data out, but I can grab this Lorem Markdown file. Just paste that in to show you what this might look like. And this is all working with Markdown, so you can put in images here, you can put in like text of different types, etc. So this could be like your methodology page. And again, that principle of like, you shouldn't have to be a developer to edit this. You can just go in and change the text yourself. Let's go back to our homepage here. We'll get rid of the text that's there and let's add in something more interesting. So in here, what we can do is we can add in what we call panes. And so let's add in a map pane. We'll call it map 1. That puts a little map on our dashboard. And again, like we're not coding anything here. We can just tweak all the values here. So let's make this a full screen map. So if I just set it to 0, 0 in position, and then 100 by 100 in terms of width and height. These can be percentages. We get a full screen map, which is nice. And then if I come through to the map itself, I can edit interesting things. So I can say, maybe let's give it like a nice dark base map, super easy. And then let's add a data set. So we can bring in any data set from either a CSV file with a URL. We can bring in one from a GeoJSON file. We can bring in cloud optimized geotests, which I'll show you in a second. But we can also bring the data in from the server. So any of the data sets we uploaded before and any of the APIs we defined before, we can bring in as a data source into the application. So here, let's just bring in this health factors data set. And we're going to add it to the data set here. So this will like grab the data. It'll give us hopefully a little green light when it's loaded. There we go. So that's loaded in now to the whole thing. And if I go back to my map now, what I can do is I can add in that layer to the map. So if I go to my layers now, I can see health data and select it from one of the data sets that's loaded. Health factors here. Can add that in, and then it should populate the map. So I can zoom out. This is a little bit, we want it to be zoomed out by default, so we can just click here to set the current view from the map view. So that's going to then make the map zoomed out whenever you see it, first of all. And then we can go into our layer and we can tweak some of this stuff here. So again, we can just change the fill color if we want using this nice slider. So, you know, if we wanted it just to be like polygons, we can do that. We can change the lines style. We can even do something fun with the elevation. But really we want this to be data driven. So we can set the data driven on here. We can choose a column to be data driven by. I think you had one your thought was in. Unperk. That'll number. Can anybody see it in there? I'm like, beautiful. What this does is it'll calculate the quantiles or equal area bins, etc. Allow us to tweak those. We can tweak the palette if we want. We can take a custom one, change it up to any of these. Let's just leave it as it is, but we could also change the colors manually if we wanted to. We can also change the bin edges manually if we want to as well, if there's something we really want to display here. But that gives us our map, which is really nice, which we can see kind of the values on then. We don't just want to add mapping data though. We also would want to add in things like tabular data, not tabular data, but like numerical data. So let's do that. Let's add in a scatter plot. So come in here again, and we'll see something like variable 1, variable 2 is the name. Again, really inventive. Add in a scatter plot. We can edit that. Again, set the source to be health factors, and then we set an X column. So I'm going to do unemployed Inc again, and say something like median households income.
We get a nice chart there. Dot sizes are a little bit big, so we make them smaller and maybe change up the dot color. In fact, actually, let's do this. Let's make the dot color based upon another variable. So we can have X and Y coordinates and then the dot color based upon, say, for example, some other random variable in here. So we choose one randomly. Hopefully that's a good one. But yeah, we can, so it's like a little bit of a tweak there. But yeah, we can basically tweak this so that we can sort of do it by any color we want. Let's just set it with the first one again. And so that gives us the ability to do kind of like really nice data-driven design and our things. We can put as many of these on the page as we want. We can move them around. We can stack them in different ways. And then we can also do something quite interesting as well. So let's say we wanted to filter our map here by the regions of the scatter plot. Well, we can do that if I come through to the map pane here. And if we see in our layer instance here in health data, we have on our data set filters. And so we can add filters in there for different columns. So I'm just going to add one in. I'm going to add a range filter. I'm going to select a column, say, for example, that uninsured percentage again. And I can manually set that here. So like we can set this to be some percentage. So maybe when I see this is like 20. And what I should do with any luck is, maybe not, again, we're tweaking this in real time. So it should like update the maps. Like so maybe this maybe the 20 is too high. 10. Okay, maybe that's not going to work just now. But we can also do something interesting as well. Is we can make these linked to the scatter plot. This also might not work if the first one's not working. We were tweaking this morning a little bit, so we might have broken it. But if I go through here to state, what you'll see is in the state variables. This is basically what's all the different things in the page are reporting. So if you look at the map, for example, there's a variable here, map block, where as I move this around, the numbers change for where the map is actually present here. And everything in the application actually has access to that variable. So you can pull that variable out and use it in other places in the application. And that's true for this as well. So if I do a little scrubbing here, you'll see that there's a variable in here, uninsured percent range, that will update as I move that around. And I can associate that with, if I just copy this, I can associate that with the data set, the map itself. And so if our filtering was working, which I'm not sure why it's not, but you can imagine that this idea here is we put in the value here .min, the value here .max. And then what that'll do in the real world, and this is all working properly and not in a demo, is it would filter the map based upon where the values for that box are on the chart here. And so you can start imagining building out fairly sophisticated interaction methods within the system itself. Just very, very quickly, I wanted to show you one last thing with all this, which is the ability for us to add in that cloud optimized geotiff. So this is kind of, again, our nascent raster support. So as I mentioned before, I have a raster on the NS3 in the cloud. I'm just going to get the URL for it, which is this one. And this is basically a cloud optimized geotiff. It's about 20 gigs worth of data. And what we're able to do is we're able to grab that and create a new data set, which in here is going to be our cloud optimized geotiff. We give it a location and a name. Submit that. Again, it's going to load up in a second or two. But if we go back to our map now, oh, there's the filtering finally working. Great. Or maybe it is actually, maybe it's not. There's something else is going on. But if we come in here now into our map, our data set should have loaded in, hopefully. Yep, let's go to the data set in. I can add a new layer. And then with any luck, if the internet holds out, we can bring in that data set. And then if I zoom into New York, hopefully some of those tiles will be cached already. I might not have to wait for them. We should see those slowly loading in. So like this is now pulling from the cloud optimized geotiff. It's creating like tiles based off of that. And you can imagine doing analysis in the browser with that as well, which maybe is going to work. But did that not actually add? Yeah, I'll try that again. Yeah, we'll give it a couple of seconds and that might load in. But that's kind of the general idea here. So we've got data sources that can come from the internet and be static data sources. We've got a server where you can load things in and edit data, create APIs. And we've got this front end application builder that can allow you to put all this together. And then once you're done, we'll give you a link. If you want to scrub away from The polygons are covering it up. Oh, is that what it is? So bring that again. It will give you a link basically, which gives, oh, there's a cloud.optimize geotiff coming in now, just slowly. We're looking at some optimization for this, but this is kind of like an entire world light pollution map essentially. But this gives us then a URL, which is the live version of the application that you can go to and use, and MD can then link to and actually explore and use. So again, all these different parts come together in a way that you can use anyone individually. If you want to use a server for just data storage and data cleaning and API generation, you can do that. If you want to use the data sets and the application builder, you can see here, you can do that, but you can use that within the server as well. You can use everything together to do something really interesting. And so that's where we are just now. So say we're polishing this, we're working out some of the kinks and the bugs right now. For AAG, we'll have a release that you can download and run locally or create a server from. We'll have a demo server for you to play around on as well, to kind of play around with all these different things. And that's kind of where we are currently. I'm just going to bring up the slide deck, hopefully, and then we can sort of like look through the last few slides, and then we'll call it a day. My Google Drive. Sorry about this. We're kind of a little bit technology challenged today. But yeah, that's kind of our vision. That's where we're going. Keep in the loop with us. And then if you want to find out more information for this and kind of keep up with what we're doing, there's a couple of different avenues you can do that with. Mostly if you go to Matico.app, you'll find, oh, that's all our CEO stuff. Sorry, just a second. It's a slideshow. That basically is where we can get more information and you can get in touch with us. So yeah, this is our kind of roadmap. So we're going to have a beta release, well, alpha release probably at AAG. Case studies is something we want to do over the spring. So again, like once people got their hands on this, you know, people who were interested in having sessions about this today, we'd love to talk to you. Over the summer, we're going to be working on these compute modules to do really interesting computational stuff with the data sets. And then our kind of idea is by the end of summer, we'll have our kind of 1.0 release that people can use in different and interesting ways. And so if you're interested in keeping in contact with us, Matico.app is the application. Our GitHub is Matico platform. And we have a Twitter account called Matico app, but I think because I didn't do anything with it for the first few days, Twitter banned it, thinking I was a bot. So that's no longer actually active, unfortunately. But everything else you're working on there. So yeah, we'd love for you guys to hear how this could be useful in your work. We'd love to hear how we can bring in rasters in an interesting way. And we'd love just to hear about your thoughts and ideas about what we're building here. And so with that, I'll throw it open for questions. Sorry about some of the technical glitches, but you know, it's a technical demo. It's always going to be like that.
Do you want to swap over audio to your computer? So I've got a,
You got to shift
I've
that.
got a jet. Yeah. 1 second, we're going to switch audio here in just a moment.
If anybody in the room has any questions, we'll be outside to answer them. If anybody on the Zoom call has any questions, feel free to reach out to us. And we're more than happy to chat to anybody on this effort. But thank you so much for your time, and we hope this is useful and interesting.
All right, thank you all so much.
Can I ask a question for you and Julia, for Dylan and Julia?
Yeah, sure.
So it's probably, I know people have to go and we're overtime, but I actually have a potential case that is probably bigger than you can manage by yourself, but is a good proposal idea, I think. And also I have 2 people working on very similar things, you know, not building a platform, but building a visualization where they've had to work through a bunch of this issue. And the question is whether we can somehow use your whole toolkit to allow people to easily build GeoJSON files that could be displayed in our system. And if that's possible, and if we talk this through, which is more than now, I think it would be an amazing proposal idea. So you know, maybe Julia, we could find a time to have coffee or something, you know.
Yeah, absolutely. I'm on site next week, and so is Stuart and Dylan as well, and Marinia was on this call too. So let's definitely, I'll just follow up with some meeting time suggestions, and then let's get together.
Perfect. Awesome.
And Emily, I'll include you as well. Anyone else who wants to be part of this conversation, just ping me.
Fantastic. Yeah, looking forward to it. And yeah, thank you all so much.
Great, thanks again.
Super.
Yeah, thanks. Like I
Thanks.
said, Dylan, real quick. So like, I think a lot of the climate data is going towards this cloud optimized GeoTIFF like
Yeah.
stuff. So I think that's the way to go. So keep,
Yeah.
I would say keep.
Fantastic. That's what I love to hear.
Yeah.
All right, guys.
Thanks, guys.
Take care now.
Jim, if you could send us the recording link, that